So after these very basic principles, let's focus on the main topic of this course, the internet. So what is the internet? Well, in a nutshell. So we will for now not explain everything, but the core concepts. So what is it? Well, in the end, it's a network of networks. In former times, there were many networks, and still today, you have many different networks, and there are even networks that are not the internet. But one of the key ideas of the internet was to interconnect different networks. So maybe you have a classical corporate network or university network, etc. And the idea there was how to interconnect them, that they can exchange data. And this requires a lot besides cables. We will talk about protocols and standards, etc. So from one viewpoint, the internet is a network of networks. What is the key idea of the internet? Well, in the end, we want to connect processes in end systems. So let's consider maybe an end system, another end system, remote end system. And on these end systems, you have your processes running. So your email program, email server, or whatever there is. So you know this from programming to start a process, and now the process, somehow this process wants to exchange data with another process. So that's the core idea. So what do we need for this? You know already some of the basics, we'll come back to this. So we cannot directly transmit any data, but first we have to use certain services of the operating system, so sockets, system calls, etc. And then the data will be transferred somehow to the other side. So down a network stack, we will have a look at this again, and then over a network somehow on the other side, there it will pop up. There are some interfaces and data is delivered to the other side. So that's the core idea. So from a very high level perspective, basically the internet, however it looks like, we'll have a closer look later, is a bit delivery service. So we give some bits to the network, and we hope on the other side the same bits will show up. Sometimes different bits will handle this. So from a high level perspective, it's a bit delivery service. But in the end, what we want to do is we want to connect processes on different hosts to exchange some data. Who's doing this? Also from a high level perspective. Well, we have certain so-called internet service providers. So companies, organizations providing the service, well, a very basic service to transfer the bits. So the bits coming from the customers, transferring them to other ISPs, a company with a data center, or a DSL operator offering the services to customers, a university network, whatever. So we have many different types of internet service providers providing this basic service. So how can we do this, and how is this structured if we talk about services offered by internet service providers? Well, also from a very high level perspective, in the end, what we have are servers offering something. So you have somewhere a server, and this server runs processes, and the processes, they offer something. So for example, I am responsible for email. I'm responsible for some web service, whatever, servers. And then we have clients, also many machines with their processes, and they want to access a service. So the classical model is the client-server model. Clients asking for a service at a server, and the servers, they answer, they offer this service. So client-server, that's the classical paradigm. We will see how we define the services, what functions we need, etc. Additionally, we have so-called peer-to-peer architectures. What is peer-to-peer? Well, basically, we have clients that can also act as servers. So the client may ask something from other system, and this system then acts as a server and answers. But also, the other system could act as a client and ask something from the first system, and then this first system acts as a server and answers. So peer-to-peer, in peer-to-peer networks, you don't have the fixed roles of this is a server and this is a client. So why do we have peer-to-peer? Why do we have client-server? So for the traditional services like the email system, the World Wide Web, we have the big servers. They store the data and they offer all their services. And then you have the relatively weaker in terms of performance clients requesting a service. So think of your mobile phone requesting something from a web server. That's the classical situation. In peer-to-peer architectures, the idea is that, okay, we have so much computing power in all these systems, so why shouldn't they also act as a server from time to time? They can be a client, can be a server. Typical applications there is if you, for example, share some data. So you distribute data like maybe an update of software, then you may have a classical big server, and the big server then distributes, let's say, a patch to the devices. And maybe now, just for load balancing, it's a good idea that other nodes access the already updated devices. Oh, can you also send me the patch or parts of the patch? Or this also has been pretty much used for distributing music, sharing music, etc. But also updating. So you can update inside the network. What is the big advantage? Not all of these end systems have to access the server. This lowers the load on server side. So you can distribute data, so updates, partial updates inside the network. So that's quite a good idea. That helps for load balancing. Sometimes it's also way faster. So you get, for example, an update to a machine from just neighboring machines without even accessing a whatever international cable or another network. So that's quite a good idea. So basic architecture, client-server systems, that's what you typically also program using your socket architectures, etc. But also peer-to-peer, so that means I'm a client, but I also can act as a server. So that's one of the key ideas, as I said, in a nutshell. So ISPs enable you to access these services. When we talk about the internet, we always have to be aware that yes, the internet is available in many countries, but not all over this planet. So basically, most of the countries have access somehow, but the problem is that some of the countries limit the access to the internet, some countries censor, some countries limit just access to certain services in the internet. For some countries, you have basically kind of single servers controlling what's coming into the country, what's going out, etc. So it's not fully available at full speed everywhere. And there are even articles showing that, okay, there is a slowdown in global growth of internet access. So when we talk about the internet, please be aware it's not available everywhere with all the services at high speed. Okay, so coming back. So what is the internet? Now we've seen some aspects, but okay, what do you think? What is the answer for what is the internet? There are many aspects. Okay, there is the service. As I just mentioned, it's a bit delivery service. So the internet is needed to transfer a bit from A to B around the globe. So that's one of the aspects. So basically, like a post office responsible for transferring a letter from A to B. Okay, that's one aspect. Other aspects. Well, if we look at the protocols, then formally the internet is the set of all reachable parties and systems servers. And this is reflected in the IP addresses. We'll learn a lot more about IP addressing, but you know the basics. So all the systems, they have their IP address, and you are part of the internet if you are reachable through your IP address. Okay, so that's the formal part. But this is where also the discussion sometimes starts. What means reachable? What about so-called private IP addresses? So private IP addresses, that means you have an address that is not reachable from the outside. Are you part of the internet? Well, if you're quite strict, then the answer is no, because you're not reachable. You can access the internet, but the internet, well, or other computers cannot access you. So, well, that's another aspect, a set of all reachable parties. What happens with company networks? So, company networks, you also cannot reach from the internet. Are they part of the internet? Yes and no. Well, yes, they can access services from the internet, but no, you cannot reach them. Then we can also discuss the topology. So the internet is basically this network of interconnected machines. So that's another aspect. So we see machines, connections, wired, wireless connection, etc. So you see, it depends on your viewpoint, what is the internet? Okay, but please be aware, the internet is definitely not the World Wide Web or Facebook or Google, whatever. These are services on top of what we discuss as the internet. So the internet is the basic underlying huge structure. And on top of that, we can have many, many different services, applications. So let's have a closer look on the topology. What do we have? Well, we have our wired and wireless end systems, also called hosts in the terminology of the internet. So we have hosts, and all these hosts, they are then connected to some intermediate systems like routers, and we have the links to connect them. So you see different types of links, fixed or wireless, for example. So you can use a cable, different types of cables with the connectors. You can use Wi-Fi, 5G systems, and whatever. Okay, so the end systems are important for you as a user. You have your interface to the network using the end systems, and the intermediate systems, they are important for the interconnection to the core. So we have the links, also called access links. We have access points. This is where we, with the end systems, then access the remaining part of the internet. The next step, we have switches, routers, interconnecting these devices. It depends on your setting, if this is all combined in one device, if you have separate devices, etc. But this is just an example. And then, typically, after you access Wi-Fi and you have a switch, a router, then this is all connected to your internet service provider using, for example, DSL, cable, fiber, whatever. And internally, the ISP then has its own network of routers interconnecting the different points here at the border where you can access the network of the ISP. We have several of them, of these ISPs, typically regional ISPs, and they are then interconnected to global tier 1 ISPs. They have global networks, these are the big players. Okay, such an ISP typically runs an own so-called autonomous system. We will come back to the idea of the autonomous systems. Autonomous system, that term already reflects one of the core ideas of the internet. Those systems are autonomous. No one owns the internet. The internet basically is a bunch of interconnected autonomous systems. And those autonomous systems, they have their peering agreements. Okay, we like each other. Okay, let's exchange data. So that's the core idea. So we cannot basically connect all systems on this planet. So there are many different ISPs. So why not do some peering with them? And the global tier one, like German Telecom, AT&T, and whatever, those big players, they have their connections worldwide. But then you have many of these regional ISPs covering just in a city, offering their services, etc. But they are all managing their autonomous network. What else do we have? Sure, we have data centers. In addition, they are typically connected to the big players, so server farms, and hopefully in a cold place where I do not need that much cooling, with photovoltaics and solar, wind energy, etc. Because the problem is, if you compute something, well, 1 watt of computing power, you need also a watt of cooling, because the major job of computers is not computing, but generating heat, at least with today's technologies. So in the end, you have many computers there, processors, etc., tens of thousands in a huge kind of a warehouse. And there you have all the services. We discussed this, and what does the cloud mean, and cloud computing, grid computing, etc. So if you want to know where these data centers are, you can get at least a rough feeling by using, for example, commands like traceroute. And then you can find out, okay, if I look, so for example, for Google or for university page, okay, where does the data flow and where are these systems? Just some quick questions. Check your own knowledge. Do you still remember from bachelor courses how you connect to the internet, how you access the internet? You have an interface. How is this done? How can you access then certain services from your process? So you have your process. The process wants to transmit something. How do you do this from a programming point of view? What kind of services can you directly access? Also, from a process point of view, what is offered? So, and if you want to find out how your computer is connected to the internet, where data flows, how can you do this? How can you find out the way? And a bit more tricky, is this really the way data flows? We can discuss this. And then I showed the classical client-server architecture versus a peer-to-peer architecture. So why do we have peer-to-peer? What is the advantage there? What is the disadvantage? What could be applications, typical client-server and typical peer-to-peer applications?